Ladies and gentlemen, good evening. Tonight we're going to talk about the Kafka broker cluster setup. So it's the last time that we talked about Kafka, then it was the basic stuff that we talked about. We talked about what is a producer, what is a consumer, and what is a broker, and that we have something called an offset that actually makes the consumer capable of actually saying that I want from offset 3 and ahead if it has been down. Let's look at Kafka. Let's look at the Kafka cluster setup and how we can actually set these Kafka brokers up so we have some kind of redundancy. I'm going to delete the Zookeeper application right here because now we just know that there's something called Zookeeper, and Zookeeper will keep track of the of the brokers. But let us just focus on the brokers right now, because right now here we have one broker Y right here. I'm going to make it a bit smaller because I want to add more brokers now. So right now we have broker Y, and we still have topic X. Then I want to create another broker right here. I think I'll make it a little bit smaller, like this. And then we have another broker right here. So we have Kafka broker, and now I'll name them X. And the topic, we could just say that this is now we'll give it a name, space flight. So that is the topic. Like this. Copy, and the topic right here, space flight again, and this is broker Y. Then I also want to have a C, so I'm just going to copy this and paste it down here. And then I want to say that we actually, I also would like to add a partition actually, so I'll just make this a little bit smaller. We have partition 1, we have partition 2, and then we have partition 3 down here. Because let's say that all these brokers here, they have been set up with some redundancy. That means that each partition needs to have a leader that actually, where we're actually getting the data sent to, and then the leader will then copy all of its events, all of its messages to the other brokers if that's how we choose to set it up. So that means that I'll give this another color. I'll give the leader another color. Let's give it this could be the lime one right here. So this is the leader right here, and then this is replicas. So this is replicas partition we've been setting up right here. So we have one leader and the others are replica. Let me just copy the partition 3 to the other servers also, to the other brokers. Whenever you hear broker, just convert that into a server in your head instead. It's not that there's not that much to it. It's just it's just a server. So then we have a leader. We need to have one leader of each partition. So that means that X, then is partition 1 that is leader. Maybe on Y, then it's on Y, maybe it is the leader of partition 2. So let us just choose that right here. It was almost the same color. And then we have partition 3, which Kafka broker C set is the leader of. So I'll just choose that lime color there. And that means that every time we get a message on one of these partitions, then the leader will then copy all of these messages to the other brokers which we have in the cluster. So this is our Kafka cluster that we have right here. Cluster. So we have all of the Kafka cluster right here. So every time we get a message into, let's say, partition 2 right here, then we need to, then we will copy it. I could just bring it to front right here, arrange, bring to front. So then we get this into partition 2 right here. Then after some time, or very fast actually, then this will be copied to partition 2. And it will also be copied to partition 2 right down here. So these are copies. So let me also give these other colors. So these are copies. I'll just give them just a slightly lighter color. Copy and copy right there. So these two are copies, and then we have the message that was initially sent from the producer right here. The producer will only get okay when the Kafka leader has copied the messages to the other brokers in the cluster. So that means that there's a lot of writing going on between the brokers, a lot of communication right here, but it also gives us a lot of stability, because let's say that now the Kafka broker Y right here, which is the leader of partition 2, it breaks down, it fails. So then there are two situations. One is that simply we will just wait for Y to come up again, and then we will continue sending on messages whenever it comes up. Then we will continue to give it some events or messages right here. That is one situation. Another situation is that it never comes up again. It now fails, and then one of the other brokers can actually take over and become the leader. So let's say that we have actually sent two messages, two events to partition 2, and now it breaks down. So something happens. So now broker Y actually dies, but it has not yet copied the event to the other brokers yet. So that means that actually when we then mention and say that now Kafka X should be the leader, which we can just set up to happen automatically, of course, and then let me just do that. Then we take the line right there. So now this X is actually leader of partition 2, because broker Y is totally gone. It has been taken out from our system. Then this event that we have right here, of course, this will not be replicated up to X right now, so we will actually lose that event. So that is the downside, but the good thing about this is actually now we can actually continue producing messages and producing events to the second partition like this, and then of course these messages will then also be copied to the broker set right here. So that would just work as usual. So that is the good thing. We are actually talking about, when we are talking about Kafka, then we're talking about at least once or at most once. So that is two principles that we're dealing with, and usually it is at least once. So that means that messages could actually sometimes be consumed multiple times, and that could actually occur if a consumer consumes a message and some error occurs before it actually has committed the offset and said, okay, this is okay, then let's say that the consumer actually breaks down, then the consumer, when it starts up again, then it will actually get the same event again. It will actually get the same message again, because it hasn't committed the offset that for the event that it handled in the first place, because some error occurred. So that is the at least strategy. That means that then messages can actually be handled multiple times. If you say at most, if you use that as the strategy, then if an event has been tried to be handled by one consumer, then it doesn't matter that it was handled correct or not. It will just disappear after the consumer has handled it. So, but usually, So that is actually the setup. So it's actually a bit more complex when you start dealing with clusters. But usually it is, of course, the people who set up the Kafka cluster who has this headache, if you will, or the possibility to tweak the system. As a consumer or a producer, then usually you would just get the name. You would just get the bootstrap address for where to send the messages, and the same with the consumer. You would just get some address where should you consume messages from, and that's actually it. I think this is what I want to tell you regarding the Kafka broker and the cluster setup. We are going to look into how to actually code this in a Spring Boot application very soon, but not in this episode. Thank you very much for listening, and have a great evening. And feel free to ask questions in the as usual in the comments. Thank you very much. Hope to see you again soon. Bye bye.